Okay, so in this question, we are going to solve this logarithmic equation, this exponential equation. So notice here we have the formula, the equation e to the negative 2x is equal to 3 to the quantity of x plus 1. So we have x plus 1. Notice in this circumstance, we are going to have to remove these exponents that have variables. We're going to have to take the variables out of the exponents. So the best way to go about doing that is to go ahead and take the ln of both sides. So we take the ln of both sides. This will allow us to do one unique property. We'll have one unique property. So in this circumstance, that will allow us to pull the exponent out to the front, and we will also do the same over here. So this will give us negative 2x ln of e. So negative 2x times ln of e equals to the quantity of x plus 1 times ln of 3. So I use my logarithmic properties to pull the variables out of the exponent, and ln of e just gives you value of 1. Remember, ln of e is really log base e of e, and remember, this states e to what power gives you e, and that clearly has to be a value of 1 because e to the 1 is that question mark. Therefore, we know ln of e has to equal to a value of 1. So here we're going to have negative 2x is equal to x plus 1 ln of 3. In order for us to solve, we have to get our x's on the same side. So I'm going to distribute this ln to both sides. So I'm going to have x ln of 3 plus 1 times ln of 3 is just ln of 3. So I'm going to go ahead, I'm going to subtract ln of 3 on both sides. Subtract ln of 3 on both sides, so I'll have negative ln of 3 minus 2x equals to x ln of 3. Now I'm going to add 2x on both sides, so I will have negative ln of 3. This 2x and negative 2x cancels, and we'll have x ln of 3 plus 2x. So hopefully now we recognize that we have an x in this term and an x in this term. So hopefully we can know that we recognize we can factor these x's out. So on my left side, I'm still going to have negative ln of 3, and that's going to equal to the quantity of ln of 3 plus 2 all times x. In order for me to solve for x, we're going to divide both sides by ln of 3 plus 2, and we're going to divide both sides by ln of 3 plus 2. This cancels, so x will be equal to the negation of ln of 3 all over ln of 3 plus 2. So if you have to go back and you're a little confused on this, and logarithms, they do take some practice. Review your logs, your logarithms and natural logs. I much prefer working with my natural log, ln, this is the ln, than I do my logs. And you could accomplish the same method of solving using logs. You can use any actually log of any base. The most pragmatic is log base 10. However, that's not the only one. But specifically, I like working with natural logs because I don't have to worry about bases, and it tends to be, for some reason, it looks cleaner to me. So now on to our next question. So now we're going to solve the following equation. So notice here we have more variables in our exponents. So I'm going to write this out so we can all see this. E to the 2x is equal to 3 to the 2x power. So again, whenever we have variables in our exponents, I know I'm thinking I want to take the natural log of both sides. By doing so, I can bring my exponents out to the front, just like such. So, doing that, I can bring out my 2x, and I have ln of e, so I bring that 2x out front, I'm left with ln of e, and that equal to 2x over here times ln of 3. Okay, so we know ln of e is equal to a value of 1, so I get 2x is equal to 2x ln of 3. If I want to solve for this, make sure not to make the mistake of just canceling out your x's. You can't do that. So we're going to subtract 2x on both sides. So I get 0, because this cancels and we get a value of 0. 2x ln of 3 minus 2x. Hopefully now we recognize that we can factor out a value of x. So we get 0 is equal to, we can actually factor out a value of 2x. So let's factor out 2x. So we'll be left with ln of 3 minus 1, still times 2x. In order for us to solve, we can divide everything by ln of 3 minus 1, and we're going to divide this side by ln of 3 minus 1. 0 divided by L to the 3 minus 1. I'm going to continue this up here so we can see it. 0 divided by this is just a constant, and 0 divided by anything will always give you 0. So we have 0 is equal to, now this canceled over here, and just a value of 2x, and dividing both sides by 2 here, we get 0 is equal to x. So the only way we can solve this is by letting x equal to 0. And again, we can plug this in and check ourselves. This would be e to the 2 times 0 would have to equal to 3 to the 2 times 0. E to the 2 times 0 is really e to the 0 equals 3 to the 0. E to the 0 is 1. That equals 3 to the 0, which is also 1. 1 equals to 1, so we know we have the right answer. Continuing on, we are allowed to use any method of our choice to find the solution set of the following equations. So notice here we have 2x minus 2y is equal to 1, and then we have x plus 2y is equal to 3. This actually lends nicely to the elimination method. The elimination method states you are allowed to add two different equations together in such a fashion that one of their variables will cancel, and the resultant equation can be used to determine the initial variables. So notice, if I were to add these two equations together, notice my negative 2y plus my 2y would cancel, and this gives me a value of 0. Noticing if I do this left to right, 2x plus x gives me a value of 3x. This goes to 0, and I get 1 plus 3, which is equal to a value of 4. Solving for x on both sides, I get x is equal to a value of 4/3, but in order for me to solve this, I have to determine both values of x and y. So I'm going to choose, and you can plug it into either equation, it does not matter. So I have x plus 2y is equal to 3. I'm just going to go ahead and solve for my value of y at this point. So I know that 2y will be equal to negative x plus 3. I subtracted x on both sides. I guess I could have showed you that. I'm sorry about that. So I subtracted x on both sides, and now I'm going to divide everything through by a value of 2. So I get y is equal to negative x plus 3 all over 2. Now I'm just going to plug in. So I'm going to have negative 4/3 plus 3 all over 2. Negative 4/3 plus 3. Remember, 3 is really equal to 9/3. 3 is equal to 9/3 because 9 divided by 3 is equal to 3. So this is really going to be negative 4/3 plus 9/3 all divided by 2. Negative 4/3 plus 9/3 is equal to a value of 5/3 all divided by 2, which is really 2 over 1. This will get multiplied here. The 1 gets multiplied here. So I get y equals to a value of 5 times 1, which is 5, all over 2 times 3, which is 6. So this gives us the final solution of 4/3, comma, 5/6. On to our next question. This one's a little bit more going on here, but that's okay. So in order for us to do this question, we have to determine the function's vertex. We have to determine the function's vertex, axis of symmetry, and all intercepts. All intercepts meaning x and y intercepts. And plus we have to graph it. So I know sometimes it's easier for me to find the vertex, and you can use either the complete square method, you can solve by completing the square, or you can use the formula negative b all over 2a and then f of negative b over 2a. This tends to be a little bit more expeditious, especially on a timed exam. So let's go ahead and find, and this is going to be the equation for the vertex of a quadratic. So in this circumstance, my a is equal to negative 1, my b is equal to negative 8, and my c is equal to 10. Notice I get that negative 1 from this leading coefficient, which is my a. And remember, this falls in the form of ax squared plus bx plus c. A leading coefficient, a is negative 1. B is the coefficient of the x, b is negative 8. C is the constant, c is positive 10. Sorry, for some reason my stylus keeps erasing values. So c is equal to positive 10. I'm going to plug this into my vertex formula. So I get b is equal to negative 8. So I'm going to have negative b over 2a, which will be negative 8 all over 2 times negative 1. So I'm going to get 8 all over negative times negative is a positive 8 over negative 2. So I get a x value of negative 4. If I want to find what this is, I'm going to find the functional value of negative 4, and that will equal to negative 4 squared minus 8 times negative 4 plus 10. If I have negative 4 squared, I get positive 16, and this should be a minus. I don't know why it keeps deleting that. So negative 4 squared will be 16 times a negative, which gives me negative 16. Negative 8 times a negative 4 gives you a positive 32. That's a positive 32, still plus 10. Negative 16 plus 32 is positive 16. Plus 10 equals a value of positive 26. Therefore, I know my vertex is equal to a value of negative 4, positive 26. So I'm going to go ahead and I'm going to draw my my y-axis as best that I can here. And then I'm going to have my x-axis that is right here. So I'm going to say that this will be a value of scale negative 1, negative 2, negative 3, negative 4. And then I'll say each one of these, each value of 2 units will give me a value of 10. So 1, 5, 10, 15, 20, 25, 30. So 25 will be 5, 10, 15, 20. 25 is right there. 30 is right here, so 26 will be approximately there. So I know my vertex will be approximately right here. So this will be my vertex of negative 4, comma 26. You can draw this to scale. It doesn't have to be perfect science, just something that shows a depiction of where your vertex exists. And because our leading coefficient is negative, I know that this guy is opening down. So from this, I recognize very critical points. I notice that I will have 2 x-intercepts where I've highlighted in blue, and then in red, I note that I have 1 y-intercept. So I can find my intercepts by looking at my blue and looking at red. Well, not necessarily by looking at it, but I know that I have 2 real x-intercepts and I have 1 real y-intercept. But before I do that, I want to identify the axis of symmetry. My axis of symmetry is very unique because the axis of symmetry is defined by a vertical line that is drawn down the middle of the parabola that bisects this parabola in half. And notice that it's just going to be the equation of the x value of the vertex, which is going to be x equals to negative 4. Your axis of symmetry must always be in the form of a vertical line, which will be x equals to negative 4. So that'll be your axis of symmetry. So now we want to find our x-intercepts. We're going to find our x-intercepts. So our function is negative x squared minus 8x plus 10. So I'll write that here so we can see it. F of x equals to negative x squared. Negative x squared minus 8x, and I believe it was negative x squared minus 8x plus 10. So we're going to have a plus 10 here. So if I want to find my y-intercept, I set x equal to 0. So we are finding f of 0, which will equal to negative 0 squared minus 8 times 0 plus 10. Well, I guess I drew this off a little bit. It wasn't really good to scale. So, so this will give me, make sure I drew this out correctly. Yes, I did. So this will give me a 0 here. This will give me a 0, and then I get a value of plus 10. So in actuality, I should have drawn this so it intersected right here. So I'm going to go ahead and try to do that so I don't make that mistake. So I'm going to erase this portion here. Whoop. And right there. So let me redraw this so it's more to scale. So here, this should actually intersect at here at 10 and go all the way down. So I know this is not perfectly a parabola, but I just want to make sure we can see that it's going to intersect at this critical point at 0, 10. Intersects at 0, 10. So we're going to expect a x-intercept that is on the positive x-axis and another x-intercept on the negative x-axis. So let's go ahead and find that using the quadratic formula. I'm going to set this guy equal to 0. So I recognize my a is equal to negative 1, my b is equal to negative 8, and my c is equal to a value of 10. Solving this, I will have the x value, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging this in, I'll have negative 8 plus or minus the square root of b squared, which is going to be 8 squared, minus 4 times a, which is negative 1, times c, which is 10, all over 2 times a, which is negative 1. So we're going to have negative 8 plus or minus the square root of 64. Negative 4 times negative 1 is positive 4, times 10 is a positive 40, all over, this is plus or minus, sorry, it keeps erasing things on me, all over negative 2. Simplifying this continuously, we will have x value equal to negative 8 plus or minus the square root. 64 plus 40 gives me 104, all over, this is plus or minus, all over negative 2. Simplifying more, I realize, okay, I can factor out a value of 4, so let's try a value of 4. So we're going to have negative 8 plus or minus the square root of 4. 4 goes into 10 2 times, remainder of 2. 4 goes into 24 6 times, and so that will give us root 4 over times root 26 all over negative 2, and this gives us negative 8 plus or minus 2 root 26 all over negative 2. And we can divide this out, so we'll get 4 plus or minus root 26. So these will be my two x-intercepts.